Hi everyone, welcome to our video about nuclear power plant. We are group 1 and that includes Fazlis, Faris, Nizam, Tuti and me, Lukman. Introduction and basic principle of energy.
Nuclear energy is produced through a process called nuclear fission. Inside the reactor, atoms such as uranium-235 are split by neutrons. When the atom splits, it releases a large amount of heat. This heat is the main source used to produce steam. The basic principle is simple. Reactor produce heat, generate steam, rotate the turbine and produce electricity. This is the fundamental process of how nuclear energy is converted into electrical energy.
Main component of nuclear power plant.
First component, nuclear reactor. The nuclear reactor is the core of the entire plant. Nuclear fission occurs in the reactor core where uranium atoms split and release a large amount of heat. Second component, steam generator. Transfer heat from the reactor's primary coolant high pressure water to a secondary water loop. The primary coolant does not boil due to high pressure. The secondary water turns into high pressure steam. In some reactors, example boiling water reactors, steam is produced directly in the reactor. Third component, steam turbine. High pressure steam enters the turbine and spin blades attached to a shaft convert thermal energy into mechanical energy. Fourth component, electrical generator. When the turbine spins, it rotates a magnet inside coils of wire. Electricity is generated through electromagnetic induction. The electricity is sent through transformers to increase voltage for transmission.
Advantage of nuclear energy. It is one of the most efficient energy sources. Even a small amount of uranium can generate a very large amount of electricity. Nuclear power plants produce extremely low carbon emission, making them a strong option for reducing pollution and helping to fight climate change. Nuclear energy provides stable and continuous power, ensuring a reliable supply of electricity to meet the country's consistent and growing energy demand.
Risk and safety measures.
Although effective, nuclear energy does come with risks. The potential for catastrophic accident, uncontrolled reaction accident, natural disaster and long-term disposal challenge for radioactive waste, human health impact from radiation exposure and susceptibility to natural disaster. One of the main concerns is radiation, which can affect human and the environment if a leak occurs. However, modern nuclear plants are designed with multiple layers of safety, including ultimate control system, protective containment structures, and emergency cooling system. Safety is always the top priority in nuclear operation. Example, the incident happened at nuclear power plant in 1986, 2011, and 1979.
Chernobyl. Safety test went wrong combined with the flaws in the reactor design. This has caused a massive explosion. However, Fukushima Daiichi, caused by a natural disaster change, a massive earthquake followed by a tsunami that disabled the plant's power and cooling system. Lastly, at 3 Mile Island, combination of equipment malfunction and human error led to cause a partial meltdown of the reactor core. In conclusion, nuclear power plants play an important role in supplying clean, stable, and high-capacity energy. Although there are risks, modern technology and safety systems help ensure safe operation. In the future, nuclear energy is expected to remain one of a key sources to meet a global energy demand. Thank you.